All right, here we are in the B part of section 4.3. Still more right triangles, still SOHCAHTOA. TOA. The differences, of course, we'll still be drawing some triangles, of course, but the difference, we're going to be using our identity sheet a little bit more today. So make sure you have yours handy as we go through some of these different problems. So just a little quick vocab review here, doing the different parts of the triangle. What is the length of side? What is the length of the side opposite of theta? Opposite, of course, is 5. Hypotenuse is our longest side, 13. Sine, of course, 5/13. Cosine would be adjacent over the hypotenuse, all things we know. Then it says divide your answers. So they want to do 5/13 divided by 12/13. Of course, when we divide two fractions, we're going to multiply by the reciprocal. So our 13s will cancel each other out. We're down to 5/12. So what trig ratio does 5/12 represent? Well, 5, of course, opposite, 12 adjacent. So that, of course, opposite, adjacent, tangent. So using our identities, of course, we have used it in the past. We know that tangent, of course, is sine over cosine. This is just reinforcing that for us. So you definitely got to have your identities handy, and we're going to do some real world problems. Just basically, we got to read it and draw our own triangle and solve for a side. So complete the following identities. These are directly off your identity sheet. The cosine of theta equals 1/secant. That is the reciprocal identity at the very top of your identity sheet. Cotangent. We know it's 1/tan, but they don't have the 1 filled in. So we also have the quotient identity for it, cosine over sine. Cotangent of 90 minus theta, that is under your co-function identities. The co-function of cotangent, tan. So literally just filling them right after the identity sheet. Hopefully maybe you knew those first two though. Okay, use the function values and trigonometric identities to evaluate. So we've been drawing the triangles in the past. We're going to try and do them a little differently this time, and of course do it all off our identities. So let's start with our easiest stuff. If sine's a half, you know cosecant. Of course, the reciprocal, I'm just going to put 2 down for that. If we know tangent is √3/3, we can get cotant. It's going to be the reciprocal. Now, notice I wrote it underneath because I knew I was going to have to rationalize. I was worried I'd run out of the room if I put it all on the blank there. So our 3's cancel out, so I can put in cotangent, √3. So next we need, of course, cotan of 60, and we need cos of 30. Well, a couple different ways we can do this. Let's do first off cos of 30. So let's work on our 30-degree angles. So we have tan and sine. We know tan, of course, is sine over cosine. So I know my tangent's the √3/3. They gave us sine was a half, and we're trying to find the cosine. So now I'm just going to use some algebra and try to solve this. I'm going to clear out that cosine denominator. And then, of course, to get cosine itself, I need to divide up this √3. So now I'm just down to doing a whole bunch of fraction work. I'm going to have to do 1/2 divided by √3/2. We're going to multiply by the reciprocal. 1/√3, which of course rationalizes out to √3/3. So using your identities and some solving skills. Now, cotan of 60, we can of course use an identity for that. The co-function of cotan, of course, is tan. That's going to equal the tan of 30. That's off our identity sheet. And they gave us tan of 30. I can just fill it. Now, a lot of identity work. Of course, you could always just draw your triangle. They tell you the sine of 30, of course, opposite hypotenuse. This would be your √3, and you can go through and answer them that way. Of course, label this guy 60, and use your 60-degree angle, of course, for cotan of 60. I don't know if one's really shorter than another. As long as you can fill in the answers, I'm going to be happy with you. Okay, let's do what we can do here off the given. Tan of beta is 3, so we can do the cotan. Now, our co-function, I'm looking at this tan of 90 minus beta. The co-function of tan, of course, is cotan, which we just filled that in. I'm going to copy that down. Now we, of course, need some of these other functions. So we have to kind of look under our Pythagorean identities to help us a little bit on these. So I'm going to jot down the Pythagorean identity I'm looking at, because we need cosecant, of course, and we'll get to cosine. So I'm looking at my Pythagorean identity. Cosecant squared equals 1 plus cotan squared. So we're going to figure out the cosecant. So cotangent they gave us, or we figured out from the reciprocal. 1/3 squared, square the top, square the bottom. I'm going to add 1 1/9. I'm going to write it as an improper fraction. I just think it's a little easier. 1, of course, is equivalent to 9/9. 9/9 plus 1/9. And then I'm going to square root it. So I'm going to have the square root of 10, square root of 9. So we can go ahead, of course, and fill that in. Okay, the last thing, of course, we need is cosine. So we're going to, of course, work off our identities here again. So, of course, cosine relates to sine and tangent. Tangent, sine over cosine. We're not given sine, though, so that's not going to help me. So I'm trying to, of course, look at some other identities we could possibly use. Well, cosine and secant, of course, go together. If I can get secant, I can flip it to get our cosine. We're going to look at our Pythagorean identities. We do have one on there for secant. Secant squared equals tangent squared 1. And we do know, of course, tangent. Tangent's 3. 3 squared plus 1, 3 squared 9 plus 1, 10. And then, of course, we're going to square root it. So I know secant is the square root of 10. Now, if you like that in a fraction form, of course, it's over 1. So now, to get cosine, our last thing, I'm just going to use the reciprocal. And then, of course, we would have to rationalize it. So I'm going to end up with root 10 over 10. So again, I don't know if it's any faster than just trying to draw yourself a triangle from the given information. I'm going to label one of these beta. We have tangents 3, so we know opposite, adjacent, and then you could find your missing side and run through and figure them out that way. Said to use identities in the directions, so that's why I did go through and use some of our identities. But again, as long as you can get the answers, I will be very happy with you. All right, find the value of theta in degrees. 0 degrees less than theta less than 90, then the radians without a calculator. Now first, we're going to have to draw some triangles. This is telling you where to draw it. Between 0 and 90, I know my triangles are going to be in quadrant 1. So let's start with that. Start with the easy part. Quadrant 1, I'm going to make my right triangle. Now, I see square root of 2, so we know we're on the 45, 45, 90. And if I did cosine of this triangle, I'd have adjacent over hypotenuse. And when you rationalize it, you get your root 2 over 2. Now, final answer, though. It says find the value of theta. Theta is the angle measurement. I want to know that it's a 45-degree angle. And then they just want you to also list it in radians. So you can times by your pi over 180, or of course just know this is a common one. It simplifies to pi over 4. So this time they're asking you to figure out the angle measurement. So you're going to have a lot of 30, 60, 45 answers. All right, still in quadrant 1, so let's get our triangle drawn. Okay, tangent 1 over 1, so let's pretend we don't know what this is, opposite, adjacent. So my hypotenuse would be root 2. Again, we're on the 45, 45, 90 triangle, so my angle is 45 degrees again. And pi over 4 in radians. So because they're limiting you to quadrant 1, all of these answers are going to be 45, 30, or 60. Eventually we will move around to the different quadrants and get some different angles, but hey, it's the first time we've done this, so we're starting off easy. All right, let's take a look at this guy, still in quadrant 1. So I'm going to draw my triangle. Okay, sine. So we're trying to figure out the angle. Sine, opposite, hypotenuse. So this is one of our special right triangles. Our missing side is root 3. So this time we're on the 30, 60, 90 right triangle, and we just have to know across from the side that measures 1 is the 30. So that's going to be my answer, and then we're just going to convert it into radians, although we probably know this one, pi over 6. We're just listing both degree and radians because that's what the directions wants from us. Okay, cotan, root 3 over 3. Still in quadrant 1. Now, I always think it's easier to work in the main 3 trig functions. So if you know that cotan's root 3 over 3, we know tangent is the reciprocal of that. And then, of course, we would rationalize. So I have 3 root 3 over 3. So I'm going to label opposite root 3 adjacent 1. Our hypotenuse, of course, on our common triangle, 2. Once again, we're on the 30, 60, 90. Opposite root 3, of course, is our 60-degree angle. So there's my answer. We're going to convert that into radians times by pi over 180, or hopefully we just know it, one of our common ones, pi over 3. So you are getting the angles today. And like I said, you're going to have, 30, 60, 45, because we're restricting you to quadrant 1. All right, a couple of real-world problems here. You're going to need your calculator, of course, for this. You were 200 yards from the river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle, theta, between the path and the river's edge. In the picture here, they've got, and it wants to find, of course, the angle between the path of the river's edge. So I'm looking at the sides. I know the opposite side, and we know the hypotenuse. So we are going to use the trig ratio sine. So sine of theta equals opposite over hypotenuse. And of course, 200 over 400 reduces to a half. So the question is, what is this angle, theta? Is it 30, 60, 45? Which angle sine has opposite 1, hypotenuse 2? Well, that, of course, is our 30-degree angle. You just got to know your angles. Okay, last one of these. A surveyor is standing 50 feet from the base of a large tree, measures the angle of elevation to the top of the tree is 71.5 degrees. You can see it in the picture there. How tall is the tree? So we have to figure out what trig ratio we're using from our given angle here. We want to find the opposite side, and they tell you the adjacent side. So I'm going to use tangent. So tangent of 71.5 degrees equals opposite over adjacent. Now I have to solve for y, so I'm going to use some algebra skills. I'm going to multiply each side by 50 to clear out our fraction. And from here, we're going to have to go to our calculator. Now, notice our angle, of course, is in degrees, so the first thing I'm going to check is my mode in degrees. Of course, it's not, so we're going to go down and select degree and mode, and then quit out of there. Now, I'm literally typing in that left-hand side. 50, you can put the times sign or not, your calculator will know, tan 71.5. Close up the parenthesis or not, you'll get the same answer regardless. It didn't tell me what to round to, so I'm just going to go 1 decimal point. I'm going to say 149.4. I'm going to put a label on feet. Got it. Okay, I'm just going to back up really quick just to show you one quick thing. If you're looking at this and you're like, gosh, I don't know which angle it is without the triangle, I can't picture it, here's a little shortcut on your calculator. To get the angle, hopefully you remember this from geometry. Hit second sign and then put in your fraction value, 0.5. You could do 1 divided by 2, and your calculator will also tell you 30 degrees, in case you need that. Okay, enjoy 4.3b, more right triangles. Have a great day.